There are a few things to review as we look at weighing an airplane. The FAA gives us the general equipment idea. It tells us different requirements. We have to weigh airplanes on a regular basis, or at least with Part 91. Airplanes that are operated like the airlines reweigh their airplane every few years. There's requirements for that. We look at the different types of scale, platform scales that you can pull an airplane up on. We've got different examples of scales at Cincinnati State. You weigh the airplane clean, you clean the hangar, you close the doors. You always try to weigh the airplane inside, because weighing it outside, if there's wind, it can affect the weight and balance. The key things that we want to look at here are what we're going to need to know: equipment list, standard weights, things. We looked at the equipment list earlier. We're concerned about the configuration of the airplane. What is the airplane? The state of the airplane. The airplane is going to fly. We're going to need, the empty weight implies that the airplane is empty, but there are certain things the airplane needs to fly. So the equipment list is going to tell us the configuration of the airplane, and that will be the configuration we will weigh the airplane to. Ballast is weight, and sometimes airplanes need a little bit of extra weight so they don't fall on their nose or things like that. So ballast is going to be something we're going to record, and if it needs to be subtracted because the airplane doesn't fly with ballast, we'll subtract it. A standard weight. Standard weights are things that we're going to need to know the weight of all the time. So gasoline, the weight of gas, most people use 6 pounds per gallon. But the technically correct is at 59 degrees, standard sea level 59 degrees, gas weighs 6.01 pounds per gallon. If it's cold outside at 32 degrees, avgas weighs 6.14. Same thing with jet fuel. Jet fuel is a different weight, 6.68, or some people say 6.5 is what we've used in the past. 6.68 is the accurate weight of Jet A. If we have water or oil, these all have standard weights. Oil is 7.43, or some people use the cold weather, 7.5 pounds per gallon of weight. These are called standard weights. Of course, when we weigh an airplane, we drain the fuel from the tanks, and we want the airplane to be empty of fuel when it's weighed. We did talk about an alternate means where you could fill the tanks and then subtract the fuel from your weight and balance check. But the standard configuration is to have the airplane with no fuel. This is called, we cannot take out the unusable fuel. That's the fuel that's inside the hoses and the lines. So we drain the usable fuel out. We drain the tanks. The standard requirement is to drain the oil. So the FAA says that the oil must be drained before the airplane is weighed, or we have to fill up the oil and subtract the weight of the oil from the weight. That's what we're going to call the standard. The other fluids, like hydraulic fluids and things like that, that should all be full. As we go through these steps, the FAA tells us in here that we're going to jack the airplane. We're going to look in the maintenance manual how to safely jack the airplane. Once we do that, we're going to level the airplane. The leveling points are going to be found in the type certificate data sheet. At least they're going to tell us where it's at. And the maintenance manual will probably give us better information because the manufacturer wrote the maintenance manual. We're going to level the airplane, and then we're going to weigh it just like we've done. The next points, here is the example of weighing an airplane, and they have recorded the weights, so you have to know where if you weigh on platform scales, you have to know where the scale is located, which is under the wheel, so you have to know that location. These different figures show us that we have the same airplane. It's a picture of the same airplane. They have the datum is at the front of the leading edge, in this case, and here's your distances. It would be like a negative 32 up to the nose gear and a positive 46 back to the main gear. The datum is at the firewall. In figure 3.8, the datum, now remember the datum is just the measuring point. That's the end of my tape measure. So I can measure it from the front of the airplane, or I can measure it from the firewall. It's just a number. The datum is the measuring point. It's the end of the tape measure. The datum in figure 3.8 is 100 inches forward of the wing root. So they got the wing root here and they moved it forward 100 inches and they said this is where we're going to measure everything from. That's where our numbers are going to come from. The length of the airplane didn't change. It's the same airplane. We're just measuring from a different place. There are some formulas in 3-6, 3-7. We may get into these a little bit later. I stick with the weight times arm equal moment because it's simple and it works most of the time. Occasionally, there's been one time in my career as an A&P where I had to use these other formulas. Now, these other formulas configure the airplane in different ways. Like if it's a tail dragger, here's an airplane with a tail wheel on the back of it. You can do some calculations using these formulas. And if you just follow, here's a tail dragger. You need to use this datum after the main wheels with a tail wheel gear, if that's your configuration of your airplane. You find the configuration, you use the formula exactly like they show it, and you'll come out with the correct answer. All right? But I don't like to confuse this because my formula of weight times arm equal moment is the simplest, and that's what we're going to stick with here. I did want you to know about that, and that is covered also here in Chapter 3. The last thing that we'll cover in Chapter 3, we're going to get deep into it right now, but there's a thing called mean aerodynamic chord. Okay? Mean means average. The mean is the average. So if you look here, we have an airplane that we're looking at in figure 3-16. And the chord is the distance from it's the line that goes from the leading edge to the trailing edge of a wing. All right, so they're saying what is the average width of the wing? And we'll use this later. Well, mean aerodynamic chord is used on airplanes that have swept wings. Here's an airplane with a trailing edge wing that's swept. And the mean aerodynamic chord is the place where it's the average section of the wing. If I have a chord that's say 40 inches here, and then at the wingtip, the chord length here is 20 inches because it's narrower here at the tip tank. Okay, well, where is the average? If it's 20 and 40, where's the average wing section? That is what's called the mean aerodynamic chord. We will use this later for calculations for large airplanes. But right now, I just want to tell you that's what the definition of mean aerodynamic chord. A couple other things, they got what they call Lee-Mac, which is the leading edge. The leading edge at the mean aerodynamic chord is right here at this arrow. That's Lee-Mac. Leading edge, mean aerodynamic chord. T-Mac, T-E-M-A-C, is the trailing edge of the wing, located at this other arrow. So T-Mac is the trailing edge at this mean aerodynamic chord. This average width of the wing. Thanks for watching.